Buongiorno, good morning everybody. My name is Byrne and I'm a project manager with Integrated Environmental Solutions, or IES, who are the project coordinators of the Indicate project. On behalf of I guess the consortium as a whole, I'd like to welcome you all and thank you all for coming today. And I'd also like to thank Galliera Hospital for hosting us over the last 2 days. So some key information about the project. Its full title is Indicator-Based Interactive Decision Support and Information Exchange Platform for Smart Cities, or Indicate. It's a collaborative project involving 8 partners. It started on the 1st of October 2013 and will run for 36 months. So we will finish up on the 30th of September 2016. So the consortium as a whole, we are 8 partners from a range of European cities and countries. So obviously here in Genoa we have 2 partners, we have D'Apollonia and we have Galliera Hospital. In Switzerland we have Esri, who are developers of the ArcGIS and City Engine tools. In Dublin, in Ireland, we have Trinity College Dublin, and we also have Future Analytics Consulting, or FAC. And in Dundalk, which is a city kind of halfway between Dublin and Belfast, just south of the border between Republic and Northern Ireland, we have Louth County Council and Dundalk Institute of Technology, which is an academic institute. And on the whole, we're a very well-balanced consortium. We have a lot of skills in key areas. IES, who are based in the UK, in Glasgow, we're leaders in dynamic simulation modelling. Trinity College Dublin, for example, are world leaders in optimisation algorithms and optimisation of systems. And then we have Esri and everyone else who have their own very important skills and very pertinent competencies for this project, as you can see illustrated on this slide here. So what is the overall objective of the Indicate project? So what we hope to do over the course of this project is to develop a cloud-based decision support tool that will provide a dynamic assessment for the interactions between buildings, the electricity grid, and renewable and information communication technologies. And to do this, we're going to, we have 4 key goals, which are to improve the planning, reduction, integration and optimisation systems in a city. We also are going to develop a number of key sustainable urban indicators, which will be applicable to any city. So in terms of the planning goal here, what we hope to do through our tool is to improve urban design, city planning, energy and buildings and renewable sources. So to enable the city planner, to enable the other stakeholders to very quickly and very easily adopt their city and plan their city with key goals in mind, and to kind of illustrate the best and most least intrusive manner, I suppose, in which this can be achieved. Reduction. Reduction, we hope to reduce the urban heat island effect, which is basically where the city is hotter or warmer than the surrounding countryside. We're also going to reduce energy consumption, the associated carbon emissions and the demand of fossil fuels. And this is particularly important at the minute with the European Union's demands on energy efficiency and energy reduction by 2020. For the integration step, it's going to be the integration of district heating and cooling, centralised and decentralised renewable energy technologies, and also smart technologies into the city as is. So how can we bring these in? What are the best ones to bring into the city, and how are they going to improve? And finally, optimisation. So this is just optimisation of existing energy use in buildings and existing systems, of current energy demand and also energy efficiency. And we're also going to develop these key performance indicators. So the issue with this is, for example, one study that we might conduct here in Genoa, or one set of alterations we might make in Genoa, wouldn't necessarily have the same influence as they would in Dublin or Dundalk. So by developing these indicators and what we hope to call a common city index, we'll be able to compare cities on a like-for-like basis, so that the changes that we made here in Genoa, similar changes in Dundalk, we can assess them on a like-for-like basis. So what's this going to look like? So what we hope to achieve is that we can bring in real data from the city, so energy use data, energy demand, networks and systems, and where this data is not so strong or is not to a high level of resolution or granularity, we're going to use dynamic simulation models, or DSMs, to fill in the gaps in the data. And this is all going to be fed into a database as such, which will be formed with the ArcGIS tool by Esri to form what we call a virtual city model. Now, the virtual city model is also going to have some algorithms involved for optimization of networks and systems. And all in all, this is all going to feed in through further dynamic simulation modeling to what we're terming a graphical user interface, or a GUI. And this is where the user will interact with the system. So the test sites, we have 3 test sites, and they're all examining the different goals. So on the right, or on the left, sorry, we have the city of Dundalk in Ireland, which is going to be used for examining the master planning aspect of the tool. The city of Genoa here in Italy is going to be used for integration, and so the effect of the integration of new technologies or existing technologies into the system, and it's going to affect the overall networks and grids. And finally, we have the Casala Living Lab in Dundalk, Ireland, which is I guess, a small community of buildings that are very energy efficient, and we're ongoing with a lot of data acquisition here. So the buildings are highly monitored, and this data will feed in to allow us to optimize their systems using the Indicate tool. So I spoke a minute ago about a virtual city model, and this slide kind of takes that a bit further by showing us how it's all going to fit together. So the first, I suppose, step in the project is to obtain the data. So we're going to create or use existing city databases, such as Odyssey, ArcGIS or LiDAR data, and using this we're going to create what we're terming an urban dynamic simulation model, DSM. So furthermore, algorithms are going to be developed for the city architecture, and these are going to be integrated into the dynamic simulation modelling and the VCM. The indicators I spoke about earlier are going to be created to enable a comparison of cities on a like-for-like basis, and these are also going to be integrated into the VCM, or virtual city model. And then finally, a cloud-based 3D virtual model of the city will be created, and the user will interact with this through the graphical user interface, and will allow them to make their changes and assess the results and come up with the best solution for their particular goals in the city. So just very briefly, some of the technicalities of the project, the work packages. This event today fits into work package 1, which is stakeholder engagement, but in a more general term for the project, it kind of will drive a lot of other work packages, particularly work package 2, 3 and 5. And just for tasks in particular, just so you can see where you're contributing to the whole project specifically, this workshop today is kind of straddling the line between task 1.2 and 1.3. So as you can see, these are very important tasks feeding into to critical paths for the project moving forward. So the impact. The impact of this project we've assessed in a number of different guises, I suppose, and we've tried to look at this from the different perspective of different stakeholders. So we've identified today 7 stakeholders, and I guess today is a great opportunity to develop this further. So the stakeholders we've identified are 7. We have potential investors, developers, renewable energy technology and other technology suppliers, utility companies, business communities, public communities, and the city planner. And I'll just run through one particular example of what we've done. So taking, for example, the city planner, which is the bottom right-hand one. So the city planner might interact with the tool by feeding in development plans of public buildings to examine their interactions with the city as a whole. They may use the tool to indicate how to improve building portfolio, to indicate how to balance buildings' energy use and infrastructure requirements. So, for example, creating more demand on the grid or requiring more demand on the grid, and also indicate the impact on the urban environment of future developments. And this will help move towards a smart cities or smarter cities, and in turn will potentially lead back to attract potential investors and so on. So it's very much a cyclical cycle where all stakeholders can feed into the other stakeholders at some level. So the tool is a very well-rounded tool and will be very useful for a lot of people. So technological outcomes, apologies for this slide, there's a lot of text, but the main points are in bold. So the first is a link with GIS and other real city data for our virtual city model, the creation of the dynamic simulation modelling environment at a city scale. Currently DSM is typically only a single building scale, so this will really step forward and bring it up to a regional and neighbourhood scale. Analysis methodology for evaluation and quantification of optimisation and demand response. So that's the creation of our algorithms. The sustainable urban indicators that I spoke about, and the application of these indicators for standardisation. The application of indicators for cross-European applications. Again, this is like-for-like city comparisons. The web-based graphical user interface with which the user and the stakeholder will interact. And finally, the virtual city model itself. So I guess now I'd just like to once again thank you all for coming here today. This today is a really important kind of step for us in developing our future tasks and work packages. So I would ask you to please try and get involved as much as you can, because all feedback is very, very welcome. Thank you.